Hello guys, welcome to the another video on this channel, and now I'm going to show you a quick review of my assignment, what I got and what I did in this assignment. So this is a kind of a new video in the deep learning series, and let's begin. So first of all, this is the assignment what I got, and the comment sections are the questions, and these all are the answers. So let's get started. First of all, I tried to do this assignment on iris dataset, which is a very famous dataset. We all know that in machine learning. So let's continue. The iris.csv file is located in the assignment folder. Okay, so first of all, I imported that assignment file from my drive, and this is the path of my drive. It says it's already mounted because I kind of ran it before. It is working perfectly fine. Let's move to the another question. So it says upload the iris.csv into your Google Drive, which I did. Find a path of the iris file and save it in a variable called file name. So first of all, I imported pandas as pd just to read the csv file pd.read.csv. In order to do that, I have to import a pandas as pd. So I imported it, and then after I store that location in a variable called file name. This is my drive location. I saved it in a variable called file name. After that, it says read the content of the iris.csv file and save it in a variable name iris. As it is very simple to read the content of the file, just to use a function called read csv in the pandas library. It's a pretty good function. So now the next question says show the first 5 rows of the data frame. So in order to show the first 5 rows of any data frame, just we have to use the head, and the last 5 rows we have to use the tail. We all know that. So I used the dot head as a function. So it says first 5 rows. So in my iris data set, I have these columns: sepal length, sepal width, petal length, and petal width. Basically, iris dataset contains the flowers length and width. So this is what all about. And the species, it is like which here it says it is whether it's setosa or versicolor or virginica. So then after it says please convert the last column strings to integers. So in order to handle it very carefully and very fastly, I used this 0 1 and 2 integer instead of this is setosa, versicolor, and virginica. So I converted this string to an integer. The iris species equal to iris species dot. I used map as a function to convert this into an integer, which is a pretty good function. You can check it out on a Google. After that, next question says check the first 5 elements of the data set once again after we convert it to the 0 1 and 2, and I guess it is working perfectly fine. It says 0 0 0, and if I'm doing 52 over here, it is working perfectly fine as well, because after 50 I got a virginica. So this is working pretty good, and I'm gonna do it what it's before just to avoid the length of this. Now select the first 4 columns of the data frame as the data and call the data x. It's very pretty easy. It's I called it x, and I used iloc as a function to select some particular columns and rows. So I used 4 columns here. The 4 says 4 columns. So this is the 4 columns I choose. I left the species column because I'm gonna put this as a features and that as a label. So this as a label. See over here it says select the last column as label. So y as label. Now it is time to split the data and label. split the data and label into a training and testing segment. And now for a training and testing splitting, we do not have to do manually. We have a kind of function called a train test split in sklearn.model selection. I imported that thing, and I use this in one of my data set. So it is working perfectly fine. Moving towards the next question, it is the part of that question, and it says select test data size as 20%. So I use a test size of 0.2% and random state as 1 2 3. So basically what random state does, it is not going to randomly, how can I say, it is not gonna randomly select the numbers from each and every data set. It just have a fixed number in there, so they don't change, and that way our model won't see the whole data set in a one go. It is a very pretty good function, you can say. Please check the first five row of x train, y train, x test and y test. So this is x train, x test, y train and y test. It is working perfectly fine. Now moving towards the next question, it says check the length of x train and x test. Oh, it's very pretty easy to check the any length. Just we have a common function length. If the numbers are 120 and 30, awesome, we are good. And that it's gonna be, it says 120 and this one says 30. So basically x train has 120 and x test has 30. The 80 and 20 ratio as a 80% training and 20% testing. Now please convert y train and y test into categorical and call them one hot train labels and one test labels. It is pretty good. So first of all, I import this TensorFlow and Keras library to import the categorical in this. Now I converted this y train into a one hot train labels and y test into a one hot test labels after using two categorical as a function, which is pretty good function. I'm gonna explain it later what it does. So let's see. Now I comment this, comment some of the models out because I have some models down as well, so I'm not gonna run it all together. I'm gonna show you afterwards. First of all, it says please define a sequential model that contains three dense layers. So in order to select and import a model, I had to use from Keras import models and from Keras import layers in order to import models and layers. Now I imported this model equal to models dot sequential as a model. So basically I declare this model as that this is my sequential model. After that I'm gonna add first and second layer as a 100 units, that means 100 neurons, and ReLU as a activation function. So I add 1 and 2 as a layer, and the reason is we have three classes, of course. For the last layer we need to use 3 as the number of output because we have Setosa Virginicolor, so I mean versicolor and Virginica. So we have three labels, so we are gonna use 3 as a output. And also in question also says pick an appropriate function for the last layer. So as we all know in deep learning that most of the time we use softmax as a function in order to deal with the last layer. So you have already have guessed what could be the best when we converted the labels to the categorical, of course. Oh, sorry. Now moving towards the next question, it says that please compile your model using RMS prop. I must say RMS prop is a very beautiful optimizer, and you can use it in your model and appropriate loss function. So for this I use categorical chronology because I like that personally. And accuracy for your matrix, so accuracy for my matrix, this is my compile function. And actually I got to know from the book of deep learning, so you can refer to that as well. Now another question says, please fit your model using epoch 20 and batch size 10. So I use the fit as a function, xtrain 1 hot train labels, epoch 20 and batch size 10. It is working perfectly fine. I'm not gonna uncomment this because I have three other models as well down there. I'm just gonna brief, it is just a brief review of my model. Yeah, you can copy these things and run it on your machine. I ran it twice by myself, so it is working perfectly fine. So now it says, please calculate the result evaluating your X test, one hot test labels, and see how accurate your model is. So in order to test the accuracy, I have used model.evaluate, and this is my test function. Now we repeat all we have done in the parameter. This is the next question. All we have done till 6, and in the first and second layers we use 10 units and a ReLU function. For the last we need to use 3. Okay, this is the same thing, just the difference is in my previous model I had to use 100 neurons, and over here I used 10. So basically that's it. After that I use this same RMS prop as a function, and but over here I got a, okay, I'm gonna explain this later. So now first let's see, this is the fit function, and I'm gonna test this accuracy. Now I'm going to show you something. So this is the text accuracy, and I just got 63% of accuracy, and test loss is 1.16, which is a, I mean to say this loss is there's a much difference in my training and testing set. So this model is not working perfectly fine because first of all I used 10 neurons over here in first and second layer. Instead of this I have to use more than 10. Basically in my previous model I used 100, so that was working perfectly fine for me, and basically that gave me around 90% of accuracy. So that was working perfectly fine. Besides, I have used the epoch equal to 4, so instead of this I have to increase the number of size, I mean number of epochs. Instead of 4 I can use 10, 20, 30 like that. So this way I can increase the accuracy of my model. Here I just got 63 percentage of accuracy because I used 10 as a neurons, and I guess 4 as a epoch size. uh, Here it says, please explain all we have learned in this assignment. So I have written my answers over here. So how the number of layers or hidden units could impact the accuracy of model. As I mentioned earlier, that number of layers or hidden units, which means neurons, helps us in increasing the accuracy of our model. Besides, accuracy is not only depends on hidden layers but also depends on the quality of model and training data, of course. So this is a kind of thing. The next question says, do we always suffer from overfitting? Yes, absolutely. In most cases we suffer, I must say in most cases we suffer from overfitting because it is the most common problem in every model. How can we find and manage overfitting? So we can find overfitting by measuring the accuracy and in training and testing data. As I have mentioned earlier that I saw that one of my model is performing very well on testing data and other is not. So that way I got to know from training and testing set of both the models. uh, so there are some couple of ways to get rid of this overfitting. First of all, by decreasing the complexity of model. That means you can if you have more than enough number of hidden layers or neurons in your hidden layers or hidden units in your model, then you can decrease it and then you can test it on your accuracy model. Besides, By increasing the number of epochs, you can also try to get rid of overfitting, which I did earlier. I did epoch as a 20 in my first model, and I in second I used the epoch as a 4. So that way I got to know which performs very well. Then to hold out data, that means splitting split between training and testing. We have to show our model more training data and less testing data, so that way it can figure out the common solution for that. I mean the perfect match solution. After that, I have one method called cross validation data. So basically it makes groups of training and testing data, and in each try it attacked on a different group. For example, I have two groups in training and testing, so it will go one by one on each. So that is the cross validation data. After that, it's a data augmentation. That means if you do not have much enough data on your data set or in your data frame, so you can artificially create your data. That means for example, if you have let's say image classification model, and you just have a couple of data, not much to train your model, so from data augmentation you can rotate your pictures, you can increase the size of pixels and decrease the size of pixels, so that way you can artificially create your training and testing data set. So that way you can, these are the ways you can get rid of overfitting. After that, it says please try differentiating as we did in 09. So basically I did it my way. It is the same thing, just I used hidden layers as a 80 and epoch size as a 12. Sorry, I mean 20. And the accuracy it gives me, it's 89 percentage, which is pretty good, but it's a kind of overfitting because I use epoch less just to give it a try that how it is performing, if I'm gonna reduce the size of epoch or I'm increasing the size of epoch. So this is the assignment what I got. Thanks for watching and have a great day.